Alright guys, I got a new one for you. We're going to be doing a spa install here. Going to be going out a spa disconnect here. Then be cutting this concrete, trenching, putting a spa underneath this gazebo right here. So I'm going to run some 6'3" up this wall into the attic, set a can so I can transition from my Romex down to THHN into my spa disconnect. So let's get started. It's gonna make it difficult to find a stud. And that wood goes all the way down to the ground. Well, I'm not gonna be able to find a stud, so here, just turn the laser on, make that line go all the way up and down. Not bad. Should work. Disconnect out, mark our holes, see what we get. I like to pull these covers off here, just give it a little separation there. These things will slide right out, just like that. Now you don't have to worry about it being in your damn way. Let's see where the center of that pipe would end up right there. Well, center of the hole right there. This is going to be where I want center of my pipe. Center of the disconnect also. Okay, get this lined up. Right in the center there, get it level. Alright, let's see what we end up hitting there. A little bit. Kitty. Hi, kitty. Hey. What are you doing? Let's see what we get here. Looks like there's plywood backing, so that's good. Get some screws here, these guys here, maybe some washers. That. I need some caulking. I like to use this quad seal stuff. This stuff looks pretty good. Just gonna fill these holes with, clean the dust out of these holes too. There, just make sure there's no gonna be any leaks, just like that. I need to grab a torque some bit actually. Look at that little guy, poor little tiny lizard. Let's put you to rest. Torch bit on here. I don't remember which one's which, to be honest. I think it's a 25, T25. Let's check. Yep. Get this disconnect mounted like that. Other two screwed in. Put the level back on. That way, make sure it's level. So just right there. Take this ground bars out of my way. Take this guy out. I'll put it back on later. Like that. She ain't going nowhere. Let's tighten these guys down. Make sure you guys put a little bit of sealant on these threads. That's good. As you thread it in, it'll spread it out. When you're running conduit outside, you guys need to make sure you're using actual ring tight connectors, not just compression. The ring tight's got a little extra plastic in there to seal around the conduit, and it's got this rubber bushing. So I couldn't find a 3/4 inch hub plate for this disconnect, so I had to go 1 inch, and that's why I'm installing a reducing bushing here. I decided I'm actually going to use snap toggles through that plywood. So I'm going to take this back off. Those holes to 1/2 inch. 1/2 inch. A little bit. Getting those snap toggles on the other side of the plywood is just going to give it a way better mounting surface. Bad boys over here. These ones are different. These in like that, and just bounce it around until it flattens around the back side there, and then just zip these in. Sealant on there. One more here. These snap toggles are super brittle. I don't know if I'm a fan of these. They come with 3/16 bolts. Just leave it right now. There we go. There we go. That's a lot better. It was pretty sturdy before, but now it's extremely sturdy. It'll never go anywhere. Alright. Now, I need to pipe this up and then get it through. And knock that screen out. And I'm going to get my wire ran in the attic before it gets too hot. Alright, got this Romex laid out. I'm going to shove it through this hole and then go up in the attic. Drag it over to the panel. What we're going to need up there is just hammer and some staples, basically. Need some tape. Gotta get this ladder set up in the crawl space here. After I get hammer, headlamp here. Alright guys, we're up here in the attic. My 6'3" is over there. Pretty nice attic to work in today. Nice and cool up here still. It's about 9 o'clock in the morning. It's supposed to be 101 today. So we're gonna get this 6'3" ran over there to the panel, and then use the future Smurf tube that they have stubbed up to get the wire down into the panel. Alright. Alright guys, got this all ran. My can mounted. Transition to flex. Yeah. All the way down. Got it strapped as far as I could reach. And the Romex goes down. It's all strapped. All the way up there and all the way back to the panel. Let's leave this lid here strapped up all the way down to where the panel is. Make sure you guys are strapping all your stuff. I just wanted to show you guys the other side of this run, and just like that, runs down over there. See if you can see it. Oh, I'll be having to crawl away over there. Runs down there along the studs, and then it goes down the Smurf tube right into the panel. Alright, I just want to show you guys, I got this all ran, flexed down to outside, pipe down into my disconnect. Got my wire spliced here. My ground tail didn't want to go into the hole provided, so I gotta come back up here another day to do some other work. So when I come back up here, I'll tap that hole to fit my ground pigtail, get that landed. But for right now, that's it up here in the attic. Got it all labeled up. And if you remember, the reason for this can is we're going from Romex to THHN because you're not supposed to strip this Romex and then run it down the conduit that goes outside, because inside that conduit is considered a wet location. Romex is not excuse me, rated for a wet location, so you need a transition. So this is how I do it. Alright guys, let me get this disconnect made up here. And the neutral, this is the neutral bar. See how it's got an insulator, it's not tied to the metal at all. That's how you can tell the difference between a neutral and a ground bar at this level, or I guess at this stage of electrical system. Your neutrals and grounds only get tied together at your first main disconnect breaker, the point of service. Anything after that, neutrals and grounds don't land on the same bar. In a commercial setting, you'll have a bond jumper, which is a piece of busing that ties ground and neutral, and you'll still have separate grounds and neutrals in a commercial setting, but there's a piece of bus bar that ties them together at that main breaker section. Let's get here. So power from the breaker lands on the bus terminals here, and then power from that's going out to the spa will land on the breaker here, and then we'll have a GFI here on the bottom of this disconnect to meet the service requirements for the being within 25 feet of a piece of equipment. You need to have a service receptacle, so we'll come out of this disconnect right here with the GFI for that. There we go. Now I gotta remember what I do with that ground bar. Alright, found the ground bar. Let's get this. There we go. This ground landed here, maybe. Sometimes these things come out easy. Sometimes they fight the crap out of you. This is gonna be the 1 inch that goes down underground for the spa. The reason I took that gasket off is because we're gonna be going from EMT to PVC. Anytime you do that, you have to put a bond bushing on, no matter what the voltage is. I'm gonna trim this up a little bit to get it off that connector a little bit. Just like that. Alright, here we go. Now we're gonna run a GFCI, so a little bit of bell box here. Yeah, these knockouts are a pain in the ass to get out. Gotta get these mounting tabs on here. On these threads, you guys gotta make sure you're putting sealant on here. If you read the instructions, that's what it tells you to do. Keep it from leaking. That. Put some here, like that, nice and sealed up. Some on the bottom here. Alright, get it mounted up here. Got these little lock ring wrenches. Let's give them a try. Pretty sure that's 1/2 inch. Yep. Not bad, not bad. Yeah, not bad. Not bad, not bad at all. Go. That's that. Let's get this bad boy drilled out here. This box leveled out. Right there. Oh, I forgot about that. Forgot that these things will have 1/4 inch fit through there. So let's mark this out. Level. Use a smaller drill bit here. Let's see. Right there. Flag screws here. Make sure we put some silicone on these bad boys. All right, let's make sure this stuff's level here. All right, it's a little off, so let's see if we can adjust it. Give it a adjust and get it. Go. Good and tight. Working. It's cleaned up. Nasty fingerprints off all this stuff. Alright, let's get this GFI wired up here and then we'll go make up the panel. Be done for the day. This ground landed, neutral. The reason I'm using my dikes to strip this is because I don't know what I did with my strippers. So, just like that. Alright, let's get this GFI wired up here. We'll go make up the panel and we'll be done for the day. We'll be back in a couple days to get some stuff on the inside done. And then as soon as I get a location on this spa where to stub up, we'll get this concrete cut out, trenched, call for an inspection, and we'll be out of here. And then this is a GFCI, and then you guys got to be making sure if you're putting GFCIs outside, outdoors, they're a weather resistant type. I'll say WR right here. The difference is inside on the motherboard or the electronics, it's got like a rubber coating, and then it's got stainless yokes and screws. So there is a difference between an indoor GFI and an outdoor GFI. Same thing with receptacles. They make weather resistant receptacles, so if you line loaded this GFI and had a plug downstream, which I don't line load things. I'd hate for one thing to have an issue and then it takes your whole line of receptacles out. I think that's just stupid. So that's why I don't line load unless I absolutely have to. Let's get the screws started a little bit. Get your bubble cover. Make sure you use an end-use cover. I absolutely hate these spring-loaded things. Like, I get why they're spring-loaded, so no one leaves them open. But come on, you guys, give us a way to lock these things open or easily take them off. If you guys know something that I don't know, or something that you do, let me know, because it drives me crazy. This wire down into the panel here through the future thing, Smurf tube or spare, whatever. Usually futures are not going through the top. This may be a future for solar, but they ran their solar a different way through the bottom here and into the garage. So these wires are right there, they're 40 amps. So we get our 60 amp breaker installed right here below this. Actually right here on top of this 2-pole 20. My camera's starting to die, so I'll be back as soon as I'm done. Alright, got all this all landed. Got my number 6s landed right here on my 60 amp breaker. Neutral. Breaker, neutral ground. Remember me saying earlier about how the neutrals and grounds only get landed together at the main disconnect, the main service disconnect, sorry. Here's your power coming in from PG&E. Comes up to here on those lugs, and that bar right there in the middle is the neutral, and that bar goes across behind the hot. It goes up on these bars here. And then here you have your U for ground that's connected to the ground, comes in, and then you have a cold water and gas bond that's also landed on there that bonds your metal gas piping and water in the house. These newer houses have PEX, so that could just be a gas bond. But the reason why your neutrals and grounds land here all together is the only way to clear a fault is to bring it back to the source. People that think, oh, drive a ground rod. Well, driving a ground rod, if you got high resistance, simple Ohm's law tells you that won't clear a fault. You can tie a 20 amp breaker right to a ground rod, turn it on, as long as it doesn't have super low resistance, which normally they don't. Nothing will happen. So if you had a fault out in past this panel out in the house to ground, what's happening is that ground is bringing that fault path back here to the neutral, which allows for a high inrush current to trip the breaker. So that's why your grounds and neutrals are landed together here, and you don't need to do it anywhere else. Actually, by code, you don't do it anywhere else except for right here at the main service disconnect. So like I said, you have a fault to ground. That ground wire is the path back to the source, which is the neutral, which if your fault is on this breaker here on the hot wire and it faults to ground, now this hot wire is attached to the ground wire. That ground wire is bringing the fault back to the neutral bar, which allows for a low resistance path back to the source, which will be a high inrush amperage, which will be over the 20 amps or 15 amps, and it'll trip the breaker super fast. So that's how you clear a fault, is to get it back to the source, not drive a ground rod or any of that crap that people say. Guys, got this all done. Piped up from there down. Ball disconnect, GFCI for service, and then we'll have a 1-inch EMT that comes down. We're going to cut this concrete out here and go this way, and the spall is going to go underneath that gazebo there. That fan and stuff will come out because it can't be above the spall. Yeah, so as soon as I get some cut sheet on the spall, the issue is the spall is a 2026, so the manufacturer has no information on it yet, so I have no idea where to saw cut to stub up, and I'm not even attempting it till I have a cut sheet and I know exactly where to come up at. Right now I just have a P-Touch label for spall disconnect, but I'll make a phenolic label because this is facing the west side and this will get destroyed by the sun, that label, so get it fixed up. Alright, got this panel all done. Got our breaker here, labeled spall. I'll probably go through and relabel this whole panel for them. Some of the Sharpie's starting to come off. Make it look a little nicer, so we'll be back. We got some things to add inside, some things to move. So we'll be back to take a look at that stuff in a few days.